Hello, in this video we'll be talking about a few of the ways we can use to solve a quadratic equation. We'll start with graphing. So to solve a quadratic equation in the form ax squared plus bx plus c equals 0, we're going to graph the related function, which is y equals ax squared plus bx plus c. These should look very familiar because we've been using them for factoring for several weeks. I just moved these down here to show you something. Initially, this looks like ax squared plus bx plus c equals 0. If I move that equals 0, sorry, slowing down here. If I move that equals 0 over to this side, you'll see that these are the exact same thing, except we've put a 0 here in place of the y. So if we were going to solve this top equation, we would just graph the equation where the y replaces the 0. So let's take a look at what that's going to look like with this green example. So to solve this equation, I'm going to graph this equation. I'm just replacing the 0 with a y. And from today's class, we remember that we first need to start with the vertex, which we get at negative b over 2a. There is no b value here. It's the a is 1 and c is negative 4, but there's no b value. So the x value of the vertex is at 0. The y value is going to be negative 4. So the vertex is at 0, negative 4. And now I'm going to graph a couple more points. If x is 1, y is going to be negative 3. Then I'm going to use the mirror effect to show that it is also the same way on when x is negative 1. When x is 2, y equals 0. And then I can make my graph. Something like this. Okay, now if we go back to the original equation, which is this, we're looking to figure out what x is when y equals 0. And so that 0 is taking the place of y. So when we look at the graph, what 2 points are here when y equals 0? Well, 2 and negative 2. So what we realize is that when x is 2 or negative 2, then this will solve the equation. Okay, these are called zeros or roots of the equation, which I wrote down here. So roots or zeros, and they're called zeros because the graph shows us where the graph crosses the x-axis, which is where y equals 0, right? And in this case, negative 2 and 2. So let's take a look at a few more examples. We have x squared minus 1 equals 0. So if we graph y equals x squared minus 1, let's see what that looks like. So we're going to get a vertex at 0, negative 1. And then at 1, it's 1 comma 0, and negative 1 comma 0, and 2 comma 3, and negative 2 comma 3. And when I make my graph, it looks something like that. That didn't curve up very well, but you get the idea. There we go. And so the points that cross the x-axis were at 1 and negative 1. So we would say the zeros of this are x equals 1 or negative 1. We can also call that plus or minus 1. Let's take a look at the red one. The vertex here is, remember we're graphing y equals x squared. And so the vertex is at 0, 0. And if x is 1, y is 1. If x is 2, y is 4. Looks very similar to that first equation we have there on the left, except it's just up a little bit. And let me graph one more, and then we can talk about the differences. This one, the vertex will be at 0, 1. And at 1, we get 2, negative 1 is 2, and At 2, we're at 5. So 2, 5, and negative 2, 5. And then we'll make our okay. So let's look at the differences of these three graphs. The green one crosses at 2 points, 1 and negative 1. The red one crosses at 1 point, just 0, x values of 0. And the blue one doesn't cross at all. So it turns out that the blue equation has no solution because there are no zeros. There are no places where the graph crosses the x-axis. Oops, let's make that blue. So this is no solution. The red one has one solution, and it's at x equals 0. And the green one had two solutions at x equals 1 or negative 1, also known as plus or minus 1. Because remember, these graphs are graphs of y equals, but the problem we're actually trying to solve is just has one variable, x squared minus 1 equals 0. That's why we're not having solutions as xy coordinates. We just want x values for solutions. Okay, and if you plug these in, you'll see that it works. 1 times 1 minus 1 is 0. Negative 1 squared minus 1 is 0. And here, 0 squared equals 0. We'll talk in a moment why this one has no solution, but you can see that it doesn't graphically. Another way you can solve these equations is by using square roots. So if I were to isolate this square value, add 36 to both sides, I would get m squared equals 36. And then you know that m could equal 6, because 6 times 6 is 36. It could also equal negative 6, because negative 6 times negative 6 is 36. So what we say is plus or minus 6. Incidentally, that's why this last one has no solution, because x squared would have to equal negative 1. Well, no number times itself could ever equal a negative number, so that's why this has no solution. Alright, so imagine we had this real world problem where we're making a fish tank and we want the volume to be 486 cubic feet and the height's going to be 3 feet, and we want the length to be twice as long as the width. And we want to figure out how long the length and width are. We all know that the formula for volume of a rectangular prism is going to be length times width times height. And we know that the length is going to equal twice the width because it says it right here. So I can replace L with 2W. The width, we'll just keep as the width for now. And we know the height is 3. And we also know the volume is 486. So we can solve for W. And then we can figure out length after. So to solve this, we can multiply the 2 times 3 times W times W. And now we can divide both sides by 6, which I believe gives us 81. Let's try it out. 6, 36, 42, 48. Right, okay, so that's 81. So now we know that 81 equals W squared. Now using square roots, if we take the square root of both sides, we'll get 9 equals W. But W could also be negative 9, so we have to say plus or minus 9. Okay. Now mathematically that works. Negative 9 works. However, in the real world, based on measurements and length, the width of a fish tank is not going to be negative 9. So the width in this case is 9. And so in real world cases, we sometimes, not always, need to eliminate one of the answers. So we're going to eliminate the negative 9 and just say the width is 9 feet. And then in that case, the length is going to be 18 feet. Okay. All right, that's going to be it for this video. Thanks for watching.